I'm Mark Cavanaugh for Cavi Coaches, and today I'm going to coach you up on drawing kinematic curves. So here we have a question where we're given a position time graph. We're asked to draw a velocity time graph and an acceleration time graph. We're also going to add a motion map at the end. So we have this position time graph. We have an inverted parabola. So what we want to do is we want to be able to describe the motion of what's going on with this position time graph so that we can draw these corresponding velocity time and acceleration time graphs. So how we're going to do that is we know that the slope on a position time graph represents the velocity. So we know that on a curve, we're not going to draw a slope to connect 2 points. We're going to draw a tangent line. And we can see that our initial tangent line has a positive slope. And that slope, as we draw more and more tangent lines, the slope gets less and less steep until we reach a velocity of 0. So what we're going to do is we can see that we have a positive slope. So that means we have a positive velocity to begin with. So at time 0, we're going to put a dot to represent a positive velocity. And midway point, we have a 0 slope. So we're going to draw a dot at 0. So then we draw our tangent lines on the other side, seeing that it becomes increasingly negative. So we can see that at the end, we have a steep negative slope. So we'll place a dot at the end. Now you have to remember in Physics 1 and most algebra-based physics courses, the velocity time graphs are going to be a straight line. And the reason for that is the acceleration is considered constant because in algebra-based courses, a non-constant acceleration, you need calculus for that. So we're going to look at this as a straight line, and we just connect those 3 points to draw our velocity time graph. So now what we're going to do is we're going to draw our acceleration time graph. Well, we need to know that from the velocity time graph, the slope of a velocity time graph is the acceleration time graph. So we can see that the slope of the velocity time graph is negative, so we have a negative acceleration. The slope is constant, so we have a constant acceleration. So we draw a negative and constant, which means we have a horizontal line that is drawn below the time axis to represent a negative acceleration. So we can see at the point where on the velocity time graph it crosses 0, what that means is it is switching direction. Beforehand it was going positively, and afterwards it was going negative. So at that 0 velocity, it's just switching direction. So this would be like rolling something up a ramp and then it rolls back down. So being able to describe the motion. So now we're going to sketch a motion map for this particular situation. So what we know is that it's moving in the positive direction to start and slowing down. Then it turns around and comes back and speeds up. So when you place dots for a motion map, think of taking a step each second. And if you're going to slow down at placing your foot each second, your steps are going to get closer and closer together as the dots would. Then when you switch direction, your steps are going to get bigger and bigger and bigger in order to speed up. Then we're going to connect each of these dots with our velocity vectors. And notice that this last dot here, we're going to draw a vector, but because it switches direction without stopping for an increment of time, we're just going to jump up to the next line to show that it switches direction. And the velocity vectors we can see are now increasing in length. Now we're going to add acceleration vectors. And the way I draw and have my students draw acceleration vectors is just with a 1-lined arrowhead instead of the 2 lines for the arrowhead to differentiate between acceleration and velocity. So we know that when an object is slowing down, that acceleration and velocity have opposite signs. So what we're going to do is, since velocity is pointing to the right, acceleration is going to be pointing to the left. So I add my acceleration vectors pointing to the left to show that it's slowing down. Now, when an object is speeding up, we know that the velocity and acceleration have the same sign. So we're going to continue pointing them to the left to show that it's speeding up on its return trip to its starting location. The last thing we want to do is if we use this method to draw our motion map, we can check to make sure that all of our things check out. So we have negative acceleration all the way through. We have a negative acceleration on our acceleration time graph. The slope of a velocity time graph is negative. And then the last thing we do is we look at the concavity of the position time graph. So we have a curve that is opening downward, and a downward opening curve shows that we have a negative acceleration as well. So we have negative acceleration on the motion map, the acceleration time graph, the velocity time graph, and the position time graph. So I hope this was helpful in helping you sketch kinematic curves. I hope you have a great day and an even better tomorrow.
If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.